Welcome, everybody. I want to welcome you to this event that is organized by the American Nuclear Society's Risk-Informed, Performance-Based Principles and Policy Committee. We call it RP3C. My name is Prasad Kadambi, and I'm chair of RP3C. The purpose of RP3C is to help modernize ANS standards. Modernization has come to mean that risk-informed and performance-based methods are employed to overcome the difficulties that we all have encountered with purely deterministic and prescriptive approaches and methods. We've been calling these approaches and methods RIPB for short. The Nuclear Energy Innovation and Modernization Act specifically mentions RIPB. If you look around, you will find it hard to locate any place other than ANS, outside of NRC, of course, that has as much information and guidance on RIPB as we do in ANS. Overall, there's a lot of guidance available on RIPB, but most people have not had reason to become familiar with the information. This is primarily because the conventional approaches still dominate most things we do, including standards development. RP3C has been having these community of practice events regarding RIPB and associated methods, such as systems engineering, to enable practitioners to share their knowledge and experience. We've been scheduling these sessions on the last Friday of each month. Today, we'll hear from Patrick Connolly of NuScale, and he'll be talking to us about NuScale's update to SSC classification. Patrick, go ahead, take it away, please.
Okay, thank you, Prasad, and thank you to the ANS community for allowing NuScale to present today. I'll do my best to speak clearly, and if I speak too quickly or you can't hear me, please put something in the chat. I understand we'll do questions through chat, and at the end of the presentation, we'll be able to endeavor to answer all those before time runs out. But if we do not get to them, we will be able to answer them via email. So a little bit about me. I am the programs engineer. I am the DRAP coordinator. That's one of my many hats that I wear for NuScale. I was in the nuclear Navy for U.S. Submarine Force. After that, I got out, got my mechanical engineering degree from Auburn University. Started work at Vogel 1 and 2. Worked there for 15 years. Went to 3 and 4 construction, QA and ITAC. And when I had the opportunity to work on NuScale, I wanted to do some design work to kind of bring my career full circle. So that's how I ended up at NuScale. So it's been a great journey in nuclear, and I really enjoy working on NuScale's project. Next slide, please. I wonder, Pat, here you go. This just acknowledges that the work we've done through this presentation is in concert with work supported by the DOE. Next slide. All right, so today we're going to go over a little bit about NuScale, in case you're not familiar with NuScale. We're going to do a little bit of background and the business case for our need to update our classification process. We're going to review our regulatory guidance that we use and our standards. I'll ensure that I touch on some key terms and definitions, which should look very familiar to you. Then I'll walk you through our classification process, and then we'll touch on some of the elements of risk-informed, performance-based, defense in depth, and performance-based decision-making. And then we'll, near the end of the presentation, we'll talk about the augmented requirements and special treatment for non-safety related componentry. And then I'll summarize the entire outline in one slide, and then we'll take questions as we can. So next slide, please. So at NuScale, I'm not sure you're familiar with this, but NuScale's mission is to provide scalable advanced nuclear technology for the production of electricity, heat, clean water to improve the quality of life for people around the world. We'll achieve this by providing technology that's smarter, cleaner, safer, and cost competitive. If you haven't visited our website, go to www.nuscale.com. Lots of news releases, all kinds of information you can find there. Next slide, please. So who are we? NuScale was actually formed in 2007, and with the sole purpose of completing the design and commercialization of the small modular reactor. The initial concept was the development testing since 2000 with the DOE effort with the MAS light water reactor program. In 2011, Fluor, a global engineering construction company, became the lead investor in our company. They're still one of our partners. In 2013, we got some DOE funding and has been awarded over $400 million in DOE funding since. We have greater than 560 patents, and we have nearly 20 countries with patents pending. Currently, we're over 400 employees in 5 offices in the United States and 1 in the United Kingdom. In 2020, last August, almost a year ago, we completed our review of the design certification application and received approval. So that was a huge milestone for us. And to date, we've had a total investment that's greater than $1 billion. So quite a lot of money has gone into this effort to get us where we are now. And in the slides coming, you'll see the mountain we climbed to get there. So next slide, please. So as you see on the screen, you can see the module, the small modular reactor is our core technology is the nuclear scale power module. It includes the reactor vessel with steam generators, the pressurizer, and containment in an integral package. Simple design that eliminates reactor coolant pumps, large bore piping, and other systems and components found in conventional reactors. This is a modular reactor, and it is movable. Each module produces up to 77 megawatts electric. They're small enough to be built in a factory, and they're dedicated power conversion system for flexibility and independent operation. So if you have up to 12 modules, you put the first module in, you can start making power immediately, and you can cycle the modules through outages without having to take all your generation sources offline. As I mentioned, with the 12 modules, you can see they're incrementally added to match load growth. Our flagship design is up to 12 modules, which is 924 megawatts electric gross output. Smaller power plant solutions are available for 4 module and 6 module output needs, depending on the customer's desires. So we are scalable, and that is one of the differences versus the large baseload plants. Next slide, please. So part of our product offering, as I mentioned, we have the scalable 12 module plant. That design was approved in 2020 by the NRC. We do have the 4 and 6, which is 308 and 462 megawatts. And they're all features and capabilities that are of the reference plant, which is the 12 module plant. We also have work we're doing in microreactors with 10 to 50 megawatt electric micro modules, and then 1 to 10 megawatt electric heat pipe reactors. And we also have various other R&D projects that we're in the works on. So innovative company, not just looking at the conventional ways to split the atom. We're trying to be cutting edge and see how we can make this technology work for each of us in a better way. So it is a fun project to work on. Next slide, please. So this slide here, you can see the climb that NuScale has taken to blaze the trail to commercialization. I know it's a bit of an eye chart, but hopefully you can blow it up when you get an opportunity. We can get the PDF of the slides. As I mentioned earlier, at the bottom you can see the 2007 milestone, or excuse me, 2000 milestone with the DOE program. 3 bullets up, you can see NuScale was formed in 2007. 2011, then Fluor acquired us, and then step by step. In 2013, we did secure the first customer. We have a site selection, which occurred in 2016. We have the DCA was completed and docketed, and then 2020, you jump up, you can see the NRC approved that design. So now we're working into NPM forging and fabrication next year. And then from there, we're going to begin the standard plant design, and we'll be ready for construction. And then beyond that, we're looking at the first plant delivery shortly, mid to early 2030s. So as I mentioned earlier, over $1 billion have been invested to date. You can see the climber there with his foot hanging on the 2020 approval. So a lot of work to do, and it's a steep hill to climb from there, but we're still pushing forward, and we're still excited. So topics like this are important because they're going to help us be able to bring this to fruition in a way that will ensure we have a more safe and reliable plant operation. Next slide, please. So a little bit about the background and the business need for NuScale's SSC classification update. So when we did the initial SSC classification program, we did it in 2015 and 2016, and that was to support the design certification application. And we provided the information for the SSCs, the reliability assurance program, and regulatory treatment of non-safety systems per the guidelines. And NuScale was responsible for all design. I think we're getting some feedback from someone.
Yeah, I'd like to request everybody to go on mute, please, while Patrick is speaking. If you don't mind, thank you very much for your assistance.
Thanks, Prasad. So anyway, NuScale was responsible for the design detail regarding all the SSCs and the system function categorization and the SSC classification DRAP expert panels were put together, and that review was very highly integrated. But one of the issues that we came up with was through that process, we had kind of done that with what I'll call a very academic approach. We had foresight in mind, but at the time we were focused on getting the product out. Not that we made bad decisions, but as we worked through this with the introduction of our strategic partners, we did begin to perform some detailed design, which introduced some communication and division responsibility challenges for us. So as it came about, it really brought up a question about who determines the design solution for the components based on the system requirements. So in essence, we had to pursue a different solution as we move forward with the standard design application. So we took an approach to separate the system function and the component classifications, and I'm going to walk through this on a slide later on to show you how we physically do that. The DRAP expert panel strictly reviews the system functions at one point, and then the component classification is done through procedural requirements. Once the component lists are put together, the DRAP panel reviews the compiled list of the component classifications, and then they ensure the classifications were decomposed properly, and that helps us develop the DRAP list, which, as you know or may not be familiar with, is part of Chapter 17.4 of the FSAR. Next slide, please. So on the screen, I won't bore you with all these, but you can see the standards and guidelines that we used to develop our information. NREG 800, Chapter 17.4, which is the chapter I just referenced. The witness chapter is 19.3 from New Reg 800. We also use the ANS 58.14, 2011, and then the Reg Guide 126 and Reg Guide 129. Those were part of our classification documentations that we used to implement our process with. Next slide, please. So a couple key terms and definitions that I want to touch base with you on. And I wanted to let you know that most of these definitions have come from ANS 30.3, which is pending approval, the latest, that is. And first definition and term that I wanted to talk to you about is categorization. So that's the grouping of system functions into categories to differentiate the functional role in supporting the safety analysis, whether it's safety related or not, and the PRA, whether it's risk significant or not, for the NuScale design. And then we have classification, which is grouping SSCs into categories based predominantly on the categories of the system functions that supports, the SSC supports, and that next sentence states that the component level PRA may deter a component classification from following the categorization of the system function it supports. In a nutshell, what that means is that the component level may actually show that it is not risk significant or it is risk significant, which may override a system function categorization based on the lower level information that is provided through analysis. And of course, we have defense in depth, which is a hierarchical deployment of different levels of diverse equipment and procedures to prevent escalation of AAOs and maintain the effectiveness of physical barriers. So we have many barriers in place. We have designs and procedures, all sorts of activities that we take credit for in our defense in depth. So, all right, next slide. I won't go over all these. Some of these are probably really familiar. The next slide I wanted to talk about here is the next term and definition, of course, is reliability assurance program. It applies to those SSCs that are identified as being significant contributors to plant safety, as determined by using probabilistic PRA, deterministic, and other methods of analysis, including information obtained from sources such as plant and site-specific PRA, industry operating experience, witness considerations, and expert panels. I know at the beginning of the presentation, Prasad, you talked about things just being so deterministic. In this arena here, we are also trying to ensure we can start taking credit for our PRA analysis and values as well. The next term I want to talk about is the risk-informed performance-based. You can see there's 5 elements of that. The first one is focus attention on the most important activities, establish objective criteria for evaluating that performance, develop measurable or calculable parameters for monitoring system and license performance, provide flexibility to determine how to meet the established performance criteria in a way that will encourage and reward improved outcomes, and focus on the results as the primary basis for decision making. So that's risk-informed performance-based methodology, and that's what this community practice is all about. So we're really fortunate we were able to participate today, and we welcome your feedback on the presentation at the end. Next slide, please. So the next slide is a bit of an eye chart as well. I apologize if it's a little blurry. Hopefully you can see it better in your PDF version than is on the screen. I will point out on the right-hand side, the block shows the categorizations of system functions that we use at NuScale. A1 is safety related and risk significant. A2 is safety related, not risk significant. The difference in those is that both of those would receive the full Appendix B program and the 18 criteria for QA. However, the A2s would not be considered risk significant and therefore would not be part of the DRAP program. The bottom two are B1 and B2, non-safety related, risk significant, and non-safety related, not risk significant. Again, B1 would be a risk significant, and that would be part of the those components tracked per DRAP. And I will point out that that reliability assurance program is actually implemented in two phases: the design, which we are in now, and then the operational reliability assurance program that the owner-operator licensee will have to ensure that those elements of the components that are on the DRAP list are managed and maintained going forward. So if you start at the green, well, first let me say this. There are 3 swim lanes. Those swim lanes are organized by our procedures. That was the best way for us to present the information internally. I'll start at the bottom here. The bottom swim lane is for licensing documentation. That's the final output of this information that we're going to be using it for. So we showed beginning to end where this information comes and goes to. And those applicable sections are Table 321 for SSC classification and Table 17.41 of the license for the DRAP componentry. Now, if we start here in the middle with the SSC classification procedure at the green dot, we'll work our way across from left to right. Essentially, you'll see that we're going to have a process, as I mentioned earlier, that we've broken it up into 2 different distinct activities. The first one is to identify the system functions, and then we would screen those system functions with safety and risk and readiness and important safety criteria, which we have rephrased as non-safety related with augmented requirements. That's the new terminology we're trying to use internally. ITS, as you know, has been very widely used and very seldom clearly identified and defined. So we determined internally we're going to use non-safety related with augmented requirements. However, we screen those functions against those and we categorize them. And then what we do is we have the subject matter expert develop a draft report. That draft report gets presented to the DRAP expert panel. They're in the upper top block. And then the expert panel assesses that using their operating experience, their collective experience, PRA and safety analysis, insights, assumptions, defense in depth. And then they determine if they agree with the categorizations or not. If not, there's a do loop. We go back to the beginning and have some more deliberations on those that may not have been agreed upon. If it is agreed upon, then we will generate a system function report. That system function report is basically each function that the system performs and how it was classified and categorized is either A1, A2, B1, or B2. And then then from there, you can see it comes down to a standalone report by itself. Historically, in the past, when we did the DCA, this step and the next step were combined. As I mentioned earlier, due to some complexities with our partnerships and design division responsibilities, we had to split those out. So NuScale will identify all the system functions and classify them, and then from there, our partner companies, if they're responsible for an area of design, will take those system functions and then go perform their detailed design work against those system function requirements. NuScale did not want to specify the design solutions before. We were very prescriptive, but we felt like there was a better way to handle the information and the design detail. So once the partner company completes their scope of work for design, they will compile a list of components that will be sent back to NuScale, and then those components will be classified against the system functions that they serve. Once that happens, we'll determine if they're risk significant or not, components that is, and then those lists will be compiled and sent back to the DRAP expert panel. In the upper right here, you can see the loop going up where it says compile list of risk significant components. And then that is deliberated over by the expert panel. and then the system list are scrubbed for items that are risk significant. And once those are agreed upon, those go down to the licensing activities that I mentioned earlier and populate table 17.4-1 for the risk significant componentry. So we had a real business case to try to maintain continuity in the design, but also not be over prescriptive in the solutions, and yet also allow the designer partner to come up with the components, but make sure those components serve the functions that were provided. So I know that was a quick overview of our process. We are rolling this out internally and through our new process, so this will be put to work here very shortly through our standard design application process that we're undergoing. So next slide, please. So let's talk a little bit about risk-informed, performance-based element, the defense in depth. As I mentioned earlier on previous definitions, we touched this a little bit, but we've broken this up into 3 categories that we want to discuss. The first one was defense in depth adequacy evaluations. So the approach here was to ensure that we'll contribute specific requirements to the reactor design and operations as determined by the SME and reviewed by the expert panel. And for each SSC that's presented to the expert panel in the DRAP list, the functional and performance criteria should be clearly identified. Additionally, the expert panel shall perform a defense in depth adequacy evaluation to ensure the collection of SSCs in the summary report and DRAP list that is generated provides multiple layers of defense in response to internal and external initiating events. This is where the expert panel's collective wisdom comes in. We have safety analysis, operations, design engineering, licensing, and we look at this as a holistic at each layer to make sure that we've appropriately evaluated it and that the SSCs will perform if they're on this list, and we have reasonable assurance that that will happen and it's categorized appropriately. The next bullet is consideration of the SSC classification. In the formulation of SSC performance requirements, it's important to understand the role of SSC's model in the PRA and the prevention and mitigation of initiating events and event sequences. So what this is really saying is, we really need to understand what the SSC role is and how it is actually modeled in PRA. So our subject matter experts work closely with PRA. PRA is also one of the members of our expert panel, and they help bring that risk-informed element to the panel. So the next bullet here talks about programmatic actions for reasonable assurance of the defense in depth. So as I mentioned earlier, we have programmatic controls at the risk to ensure that the risk insights and key assumptions are consistent with plant design and construction when they're implemented. These controls address the organization, responsibilities, design control activities, procedures, instructions, records, corrective action programs, assessment plans, all those things that we have to make sure that we keep nuclear safety at the top of importance. Those are all those programmatic controls that you'll see in a lot of places, and most of those are mandated and pre-prescriptive for what those are. The last bullet here talks about the controls provide adequate assurance that the risk, reliability, and performance and targets are met or will be met and are maintained throughout the life of the plant with adequate consideration of source of uncertainties. And what this really means is that we have reasonable assurance this component is going to operate when challenged, and that we have enough uncertainty or margin built in that should it be challenged in different ways that weren't foreseen, there's enough margin in there that those components will still be able to meet their performance requirements and targets. And the guidance and the defense in depth information that I just spoke about there is consistent with the draft of ANS 30.3, which is currently under ballot That should look familiar to you. Let's go to the next slide, please. Okay, thank you. So the next element I want to talk about is performance-based decision-making. Decision-making during expert panel deliberations should be based on criteria specified at the highest level that is feasible to meet functional objectives. This enables maximum flexibility for realizing the successful system performance. So when we look through the objectives here of the criteria, and it should be based at the functional objectives of the component and the system that is serving. And we need to make sure that the decisions are correlated to ensure maximum system performance. The performance is based upon decision process, and that should have the following characteristics that we've determined, which is consistent with ANS 30.3. That the objective criteria to assess performance is based on risk insights, deterministic analysis, and performance history. Quantitative and qualitative risk-informed performance-based decision criteria to support transparent and repeatable decisions. Part of that, recognition of different levels and types of definition depth when considering alternatives, including evaluation of safety margins, as I mentioned earlier. Evaluation of trade-offs on plant capital and operation costs versus risk reduction. That's the world we live in. We can't build a plant. We have the safest, best plant, so we can't build it if it's too expensive. But that's where these elements come into play to help us make better decisions, but keep safety at the forefront. Adequate treatment of uncertainties in PRE results and the impact of these uncertainties on the decision-making process. So those are the characteristics that we look for in a performance-based decision process. And I wanted to reiterate that the quantitative and qualitative examples of that would be key performance parameters used to support engineering change assessments would be one example. And another example would be safety and risk requirements in the plant technical requirements document that we have. So both qualitative and quantitative elements to that approach. Next slide, please. So I walked you through the SSC classification process, some of the defense in depth, the risk-informed performance-based criteria and characteristics. And now I want to talk to you about what we've encountered with, or how we're transitioned from the treatment of the non-safety related components. So we did a review of our process, and I mentioned earlier we were using the term important safety, and now we're transitioning away from that to non-safety related with augmented requirements. So we looked at the bases of the documents and the collection of documents that were there, the background, the references, and of course used our collective knowledge and benchmarking from out the industry. We came up with a set of criteria that we followed. So for those B1 and B2 components that I mentioned earlier that were not safety related, we would screen those against a set of questions or screening criteria that we came up with. And the screening criteria basically, it takes you through a series of 3 questions, and any question can make you classify a component as non-safety related with augmented requirements, one or any of these. So it has to be, if there are, each of these questions is answered no, then it's not non-safety related and with augmented requirements. But the first question is the non-safety related function subject to specific regulatory rules? That question really deals with at-loss, loss of offsite power, station blackout, and fire protection events. If it is, then we would classify that as safety related and with augmented requirements. And we have a pre-scripted list of those requirements that we have established that the SME and the panel would look at. Question 2 asks is the non-safety related function relied upon to mitigate a special event? For NuScale, that would be a module drop event. If it is relied upon, then that would have augmented requirements, even though it's not safety related. And then the last question is, does the non-safety related function perform a function that supports a GDC, a PDC, or a licensing commitment in the NuScale design? And what that is that, is there any other commitment that we've missed through the first 2 processes that may require us to have augmented requirements? So that's the process that we took and we revamped. Next slide, please. So our list of creation, so as I mentioned earlier, we screened the previous component list against the formalized criteria, the screening questions, excuse me. And we do that and we capture the basis for each of the functions as it's categorized against the screening criteria. So if it was augmented requirement due to question 1, we would state the bases. If it was question 2, we'd state the bases and why, et cetera, et cetera. So we also have, through the list creation, a multidisciplinary iterative approach where we walk through that process with the SME and stakeholders and management. So the end result of that process is to present a list that's been rigorously created based on functions developed with the formalized criteria. This takes some of the uncertainties out of it. And it allows us to repeat the list and allows us to be able to follow a process that is defendable and repeatable, and which is key in our reviews. And lastly, it enhances the accessibility of NuScale design and licensing basis to the outside stakeholders. We found that external partners and people outside of NuScale may not have understood the process as clearly as we did, which of course makes sense because we implemented it, but this allows someone to take the information, follow the screening, see the bases, find out what the augmented requirements are, and it's based on the system function that it serves, and then it correlates back to the process that we outlined. So I feel like this is a much improved process for us. I think we'll have better success with this, and I think we'll be better aligned to move forward with commercialization much easier because of this. Next slide, please. Okay, so summary and conclusions. I pretty much talked about NuScale and our history. So I want to summarize that part of the presentation up as commercialization. NuScale continues to blaze a trail to bring our innovative small modular reactor to the market by the late 2020s. And we continue to work with cutting edge R&D and microreactors and other parallels in our core business model. As I mentioned earlier, you can check our website for the latest information, or go on LinkedIn, or you'll find a lot of articles about NuScale out there if you're interested in more information. As far as the classification process that I mentioned, while we had a robust process and it was found acceptable, more than acceptable by the NRC, it created challenges toward commercialization, as I mentioned, and it lacked practical application based on division responsibilities because they weren't clearly defined across the participating members of design and construction. And these challenges were addressed by identifying process boundaries that align to the DORs across the participation members. And this split the DRAP expert panel review into 2 parts, as I mentioned earlier. The initial system function categorization review, and then the equipment list component classification verification. Next, I talked about defense in depth. As I mentioned earlier, the guidance is consistent with the pending ANS 30.3 methodology. We're looking forward to that getting pushed through. Also, it includes both quantitative and qualitative risk-informed performance-based criteria, which enables maximum flexibility to realize the successful system performance. And finally, I want to reiterate the special treatment of the non-safety related equipment. The augmented requirements are now streamlined and defendable, and as they provide a clear basis along with programmatic guidelines and controls for implementation that drives consistency of application across the spectrum for those non-safety related components. So next slide, please. So here you see that my email is on the slide here. It's pconley@nuscalepower.com. I'd welcome questions here in the chat, but if you think of one after we get off the chat or the Zoom meeting, you can certainly shoot me an email and we'll do our best to get back to you as quickly as possible. So that concludes the formal presentation. I did see there was one question in the chat. I believe Kent may have answered that. Yeah, thanks, Kent. So the first question was first module, and he provided a press release.
I guess there was a follow-up to that asking whether any foreign entities are interested in using this. That's Rob Hayes. Rob, if you want to state your question, you know, when you say use this, are you talking about the classification process or the NuScale module concept? I guess Rob answers procuring reactors. So anyway,
okay.
You can go ahead and answer that, Patrick, perhaps.
Yeah, so you look on our website, I believe they're on there, but we have many memorandums of understanding with many nations that we're working with. Of course, no one has signed a contract, but we do have many countries that are interested in our technology and are working with our company to do assessments to see how we might be able to help them meet their needs for power and other uses for the module. So we do have a lot of international interest. Did that answer your question, Robert, I believe?
Yes, thank you.
Okay. There's a question about how do these classifications relate to the quality requirements applied. I guess perhaps the question is related to you know, what's the relationship between specific aspects of Appendix B and the classification process?
Yeah, that would be correct. Thank you.
Okay, Tammy. The A1 and A2 componentry that I mentioned, I don't know if you were on the presentation at that time. I believe it's on slide 13. If there are components that are classified A1 or A2, those components are safety related and would be required to be procured in accordance with 10 CFR 50 Appendix Bravo, which is the entire 18 criteria for QA. So those are safety related and they would have to be procured from a safety related vendor.
Okay, can I follow up with another question on how you differentiate? Do you have multiple levels of safety related, like you know, as far as the ASME code class applied?
We
so
do
like
not.
React. Oh, okay. So is everything that you is everything that you designed to ASME Class 1 NB? Section 3.
No.
Hey, Patrick, I
It's
can, do you
designed
want
through
to?
this. Go ahead, Ken.
Sure. So we did, Patrick didn't, this is Kent Welter, by the way. I'm a chief engineer at NuScale. I'm involved in the process as well, developing the update to the process. The categorization of system functions, the A1, A2, B1, and B2, you know, are a categorization of functions, if you will. Once that categorization of function gets inputted into another procedure on SSC classification, then the SMEs will go and look at the system function categorization and then go through the appropriate seismic or ASME classifications appropriate for that SSC to support that function within that system. So we do follow, you know, a graded approach to ASME component classification once we get the input on the functional categorization.
Okay, so there's further classification. So something could be A1 something, A1 something else. Is that?
Yeah, we tried it, and then what we've tried to do is follow some international standards or some standards there to distinguish between the term categorization and classification. So what we're trying to reinforce is we're categorizing system functions with that sort of 4-box approach at a high level in the design process, and then classifying SSCs based upon ASME, seismic, rad, you know, containing tanks and stuff, et cetera. So there's a functional categorization and then a SSC classification.
I see. Thank you. Yeah, I wasn't sure if I was muted or not. Yeah, I see. Thank you.
Next question, I asked about the relationship of the NuScale DRAP with NEI 1804. I guess Patrick, Kent, either of you can talk about that, I guess.
Yeah, Patrick, do you want me to take that one?
Yeah, please.
Sure. So we're very familiar with NEI 1804 and Reg Guide 1.233. Yeah, I would say so. The categories, the definition of those categories, A1, A2, B1, and B2, and then the further sort of collapsing, if you will, of that when we look at it, sort of adding this step of looking at B1 and B2 functions, and then you know, identifying, are there non-safety systems that require non-safety related systems that require augmented requirements. Our update to the process sort of moves us closer in the direction of NEI 1804, which I believe has sort of 3 categories, right? Safety related, non-safety related, with special treatment, and then non-safety. So because we did an extensive job already employing the quote unquote old process, we weren't gonna just throw it out the window, but we wanted to update the process to make it a little bit easier for our architect, engineer, and EPC to identify the augmented requirements for non-safety related systems. And it sort of goes in the direction of those 3 sort of categories of NEI 1804. So it's similar, kind of going in that direction, but it's different.
Okay. Next question is, how do external hazard considerations enter into the SSC categorization classification?
Yeah,
So
Patrick, go ahead. You want to answer that one?
Go ahead.
And I'll take a shot too. Okay. So there's a couple ways. In the chart that Patrick showed, one obvious way is when we're doing the external events PRA, that those risk insights get evaluated and included in the expert panel deliberations and fed back to the SMEs. In sort of a more deterministic space, it expresses itself from, you know, protection of protections of the safety-related equipment. So in a practical sense, it manifests itself in the, you know, the eventually in the classification of the buildings, right? The structures that are protecting certain types of equipment that have been identified as having a safety related or not, or non-safety related with augmented requirements. So we do, you know, include the external events PRA insights, but then in practicality, since you know, most external events are, you know, high winds and floods and fires and earthquakes, it expresses itself into the structures, classification of the structures and what they're protecting and holding up.
Okay.
Yeah, and I was going to add on to that, that external events are also part of our review for the non-safety related with augmented requirements. If those are required to help mitigate consequences, then something that's non-safety related would get some augmented requirements to help mitigate that as well. So there's the review side, as Kent mentioned, and there's also the practical application side of it that goes through the review as well.
So there's a question from Gary Locklear. You know, Gary, if you would, could you just state your question, because it may be a little difficult for me to you know, reflect exactly what you're asking in the way I'm reading this. So Gary, if you want to unmute and go ahead. Anyway, while he's doing it, I'll try to read the guidance for non-safety related with special treatment. Does the process include NSR items that do not support the function, but whose failure could adversely impact the function in question? Did not see that in the criteria. I don't know if he's addressing specific aspects of the slide that you showed, but you know, perhaps Patrick, you can see what Gary Locklear has asked and respond.
Yeah, Gary's saying that he cannot unmute, but I believe I understand his question. I think he's talking about the 3-question criteria that we evaluated, if I'm not mistaken. And I will say that my computer just froze up. I was going to look into something here real quick and see. Ryan, can you answer that while I look something up, or are you got the answer to that?
I can answer that if you want. So
yeah, please, Ken.
Yeah, it does. So those three questions have some additional bullets in our procedure under that, and what, like specifically, what say 1/1 requirements for structures, seismic, or just structures like seismic class 2, if fail can't impact seismic class 1 structures, and that's sort of a rule-based, you know, compliance for design of that system and that structure, if you will. So the top criteria address a different type of questions, and once you get into, say, a specific code or standard or regulatory guide that SSC needs to comply with, then you'll start getting into additional requirements for that specific type of SSC, such as, say, 1/1 requirements. So that question is not did not rise to that top of that initial screening, but it does get addressed when you actually go through the design process and the, you know, classification of that specific SSC.
Yeah, thanks, Ken. And I was looking for some specific language that I might share, you know, just as an example.
Patrick, I have that pulled up.
My
name is Ryan Miller. I've been helping with the SSC classification process. But yeah, one of our specific functions that go through the screening questions is provide protection from adverse interactions of non-safety related component failures that could result in preventing safety related SSCs from performing required functionalities. So yes, I believe that's how that's covered, and I think answers your question.
Let's see, if
Thanks,
we
Ryan.
can just cover a couple of questions quickly. We're approaching the end. Next question has to do with the differences between this updated NuScale process and I think 5069 as well as NEI 1804. Perhaps, you know, it says, could you talk about the differences between these?
Yeah, this is Patrick, and I'll just say that from my understanding, what 5069 is really up to the licensee, the operator, if they wanted to implement the risk-informed for this componentry. We took the process based on the requirements for the DCA, and we did not comply or request to use 5069. Kent, do you have anything to add to that? I know we strayed away from that, not because it was a bad process. I think we just believed we didn't want to predetermine some items for the owner operator, if I'm not mistaken.
Sure. Yeah, that's correct, Patrick. If you look back at our process, we use for design certification. It could be sort of classified as a 5069-like process in terms of that looks like a 4-box approach, and there are you know, risk criteria of Fussell, Vesely, and Raw for determining risk significance that we got reviewed and approved. So it was similar in concept to a fixed 5069 approach, but it's obviously if you apply it to a design phase, it's going to be different sort of details than if you apply directly the 5069 process as a licensee. So this update is sort of going a little bit beyond that. We're adding additional defense and depth evaluation requirements, performance-based decision-based requirements following ANS 30.3. And we're being a little bit more specific and removing the ITS term and adding this additional category to help us sort of collapse those B1, B2 componentry that will help us be a little bit more specific in our augmented requirements for our architect, engineer, and EPC. So in summary, sort of a previous 5069-like process, again, moving a little bit more towards baby step, you know, NEI 1804 kind of a look. So I guess in a way it's a hybrid.
Okay, we are approaching the end. Maybe this is just a yes or no answer. It says, do you use Reg Guide 1.26 for ASME categorization?
Yes.
We do.
Okay. I think with that, Kent, Patrick, I should say Patrick, Kent, Ryan, thank you very much for giving us all this information about how NuScale has updated its process, and you know how I want to point out you know how it uses ANS 30.3, which I can say is really approaching the end of its journey. And I do hope that we'll be able to get it out and have it ANSI approved, as it were, very soon. So again, we are at the hour, and I want to thank everybody for participating in this community of practice session.